I fixed over 300 Synology NAS units, and I'm about to show you how to fix every single failure I've seen with this DS412 Plus. There are two common faults we see with this unit. Number one, dead no power. And number two, the blue light is blinking endlessly. We're gonna first start by diagnosing the dead no power faults. The first thing I wanna check is my power brick. To test the power brick, I'm gonna bring my multimeter into DC mode. I'm gonna put my negative lead on the external ground, and I'm going to measure the two pins that are slightly further apart from one another. That's gonna be the positive, and I should be getting about 12 volts, which is correct. That is what I'm getting. The bottom two, I believe, are ground and should not be outputting any voltage, and that's correct. But even though I am getting the 12 volt output from my power brick, that doesn't confirm that it's fully functional. So my next step is to actually plug it into the unit and then listen for any buzzing sound from it. I'm gonna put the mic right next to it, and if you listen carefully, you can hear a buzzing sound. Okay, just stop, and the unit actually shut off, and it's rebooting now. We'll wait a couple seconds. And then it shut off again. So right now the unit is rebooting consistently. I'm getting a buzzing sound out of my power brick. What that tells me is that this power brick actually is defective, even though it is outputting the 12 volts DC. These bricks are very difficult to open. I don't actually recommend you do this. They're also only about 25 bucks on Amazon. I'll have links in the video description to where you can buy these. I'm only opening it up for the purposes of the video so I can show you exactly what has failed. And as I'm opening this, I can actually already smell there is burning in this brick. So there is quite the pungent smell in here. This is so compact, and there's so much silicone goop everywhere in this brick that it's gonna actually be really hard for me to show you the damage. But whenever you do hear that buzzing sound coming out of your power brick, and if you're getting an intermittent shut off and cycling, just know your power brick is most likely the issue, even if you are getting that output of 12 volts DC. Now let's focus on the unit itself. On the back side of the unit, we have two screws. Once we remove them, we can go ahead and slide the cover. Next on the back, we actually have one more screw right over here and one here. This will allow us to remove this little module. We'll unplug the fans from it, put that to the side. Next, we have a few more screws for the caddy. Now these are silver machine screws, so we'll put them to the side, and now we can wiggle it off. Next, we'll be removing these four plastic screws. And these are coarse thread, so again, we'll put those to the side in their own pile. Now we should be able to lift the unit out. Now if I know I have a good working power brick and I still have a no power fault, my next step is to take a look at the CMOS battery. Our CMOS battery is right over here. We'll go ahead and remove it. And in DC mode, we'll go ahead and do a voltage check. We're getting about 2.8 volts. And a trick I've learned is to place a 100 ohm resistor on the positive and negative and redo a voltage check with it in line like that. This will help you get a better understanding of the voltage that's truly left, the power left. So we're getting 2.2. And what this is doing is essentially putting a load on the battery as we're doing our measurement. This is a brand new battery. Without the resistor, we're getting 3.3 volts instead of the 2.8 with the other one. Let's do the 100 ohm resistor trick and 2.3 volts. So what this tells me is that the battery that we just found in the unit is actually brand new, and that's actually true. The customer that sent in this unit did state that they just had replaced the CMOS battery with a brand new one, and both of these were showing 2.3 volts with the 100 ohm resistor. Now if you're getting less than 2 volts, that's probably a good sign that you should be replacing that CMOS battery. Now if you've ruled out the power brick and the CMOS battery, next you're going to want to remove the back shield, and we have 4 screws there. And on the back side, we're gonna focus on these two capacitors right here. And that's gonna be C556 and C559. So these two guys over here. I'm gonna place my multimeter in continuity mode, which means when I have a short, I'm gonna get a beep from my leads, and I'm gonna do a measurement. Do I get a short? I do not, and I do not. A no power fault can often be caused by those two capacitors shorting out. Now the capacitors in question are gonna be 10 microfarad, 16 volt rated. We're gonna be replacing these with 10 microfarad, 25 volt rated capacitors. If you're trying to fix the unit yourself, we will have the full repair kit available. Those are on our website, which I will link in the video description down below. For the replacement, we'll need to first remove our capacitors. I'm gonna add little blobs of solder on both sides. And then I'm going to be making contact with both sides simultaneously until the cap falls off. We'll do the same to the next one. Add a little solder to both sides. Put my iron in the middle. Add a little bit more solder. Kind of go back and forth. Oh, this one's giving me a little trouble. There we go. Next I need to clear the pads. Get rid of all that extra solder we just added. We're going to add a little more solder to only one of the pads. And before we install the replacement, we're gonna clean it up. I just sprayed some isopropyl alcohol and I'm getting rid of some of that spent flux. Now for the installation, I'm going to melt that little blob of solder we put and slowly slide in my replacement capacitor. All right, it is now locked in. We'll do the same to the other one. And this one's not flush to the board. Let me adjust it. There we go. Now we'll add solder to the other side. Now I'm actually gonna add just a tad bit more on the original side. And there we go. We'll give that a quick clean again. If your DS412 Plus unit had either a no power, a cycling on and off, or would intermittently shut off, one of those 3 repairs we just did, which is new power brick, new CMOS battery, replacement capacitors, will have resolved that issue. Next, let's tackle the blue light blinking endlessly. There are 2 reasons why the unit may not be able to boot all the way and have the blue light blinking endlessly. Number 1 is a defective EEPROM. The EEPROM chip in question is this one right over here, just to the right of the Intel processor. Now, the common way to determine if this EEPROM is defective is to do a short check from the pin number 5, which is this one over here, on the opposite side of the dot. And I'm gonna put my other lead on ground. Now a good board is gonna show more than 500 ohms. Right now it says 0.5 kilo ohms, so that's 573 ohms that we're actually reading right now. A defective EEPROM will usually show about 10 to 20 ohms. Now, if you don't have a multimeter, another trick is you can plug in your unit, which I've done, and spray the EEPROM with isopropyl alcohol. When the EEPROM shorts out, it gets really hot, and you'll see that the isopropyl alcohol evaporates. Now for us, it's not evaporating, and that's normal because our EEPROM is not shorted. Now, if you have a few fancier tools, you can also use an infrared camera. And again, the only part that's getting warm is our processor, which that's normal, and the EEPROM is not getting hot. It's staying cool. So for us, in this scenario, we can rule out the EEPROM as being defective and the cause of our issue. Now, these EEPROM chips are actually the equivalent of a BIOS chip. So they do have software on them, and I'm currently programming a replacement. And while that's programming, let's remove the original. For the removal, just like with the capacitors, we're gonna start by adding extra solder first, and I'm flooding one entire side till I have a big bridge. And using my tweezers, I'm going to slowly lift up the chip as I'm melting all the solder. And now half of it is free. I'm gonna rotate the board, and I'm gonna do the same on the other side. I'm gonna add a big blob of solder until we are able to free up the chip. Now we'll remove all of that extra solder I just added with the desolder wick. And again, we're gonna use a little isopropyl alcohol and a Q-tip to clean off the area. And same thing as the capacitors, I'm gonna add a little solder to one of the traces. We're gonna bring in our EEPROM, melt it, and slide it in. And I'm realizing it's a little bit offset, so let's make a small adjustment here. That's a lot better. Let's go ahead and lock in the other pins. And I don't have an orange dot, but I can see there's a small dot right over here on the corner, and that does line up with the dot on the board. So that's how I know my orientation. I'm gonna add just a little bit of flux on this one. Just wanna make sure I have very good flow, and it looks like we do. Since I added flux, I'm definitely gonna wanna clean that up with the isopropyl alcohol. Now in the repair kit, we are going to include these EEPROM chips pre-programmed, so you don't have to worry about that. A word of warning, however, these EEPROMs are a little bit more advanced, so if you don't have soldering experience, I do not recommend that you try this at home. Now the EEPROM doesn't actually fail that often, but it is a part that can and does fail sometimes. And now to tackle the most common problem for the blue light blinking endlessly is gonna be a defective DOM chip. So we're gonna want to remove it from circuit. We have to pinch this plastic tab and lift the DOM out. And we're gonna flip it over to the back. We're gonna wanna pay specific attention to this chip at ID location U1. It is labeled US Best UT165-L48. And very importantly, it says A0A. There are multiple versions of this daughter board with different chips. This is the only version that commonly fails, so if you don't have this exact same chip, you probably don't need to replace it. Now this chip will be included in our repair kit. However, again, word of warning, If you don't have a lot of experience, this is a very advanced chip to replace. This should not be the very first time that you're trying to solder. Unless you have a lot of experience and you know what you're doing, I do not recommend that you give this one a try. Because this chip is very difficult to identify as the fault, there's no short checks that you can do. We're gonna have to determine that this is the problem by process of elimination. So as long as your EEPROM is not the issue, doesn't have a short or doesn't get hot, this is most likely the reason why the blue light is blinking endlessly. Same as the other chips, we're gonna start by adding some solder first to all the pins. Next, I'm gonna add some flux. And for the removal, we're gonna be using both the hot air and the iron at the same time. So as I'm using the hot air, I'm also going to use my iron. Now the board is very light, so as you can see, it's moving around. Oh, there we go. It looks like we have movement. We'll knock off the board, or the chip off the board. And again, same process. We'll go ahead and remove the solder off the pads. And again, a little cleanup with isopropyl alcohol. We want to remove all that spent flux. And again, sticking with the same process that works, we're gonna add just a little bit of solder to one of the pins. You'll notice I have an arrow and a circle here, which indicates pin 1. And I also have a circle on that same corner on the chip itself, indicating pin 1. Okay, we'll slide it in. Is that good? It's not perfect, so we'll need to make an adjustment. But that's why we're only locking in one pin at a time. Okay, that looks pretty good to me. So now let's lock in a couple more pins. We'll add flux to all 4 sides again. And we're gonna start with that side I added probably a little bit too much solder to, and we'll try to spread that around. I can't get rid of all that extra solder, so we'll need to use the desolder wick to get rid of some of it. Oh, there we go. I do have a little extra on this side as well. Aha, let's attack these 2 sides next. And our final side. There we go. Again, a little cleanup with isopropyl alcohol. Something I like to do to confirm my soldering work was done correctly is to rake with a small tool like this. And what that means essentially is putting pressure on every pin. And if any of them move, that would tell me that they're not correctly soldered in. And if none of them move, that means I did my job correctly. So far, so good. Okay, we're all set. Let's reinstall the daughter board. And now we can plug the unit back in. Let's give it a few minutes and see what happens. Until the unit fully boots, we're not gonna be sure 100%, but as far as I'm concerned, our issues were twofold. We had the power brick was defective, and number 2, the U1 chip on the daughter board was also defective and required replacement. So for this unit, we had 2 repairs that we had to do. We did not have to do the capacitors, and we did not have to do the EEPROM. The CMOS battery was already done for us, so we didn't have to replace that either. But all of those parts are gonna be included in the repair kit. Hey, and it looks like our unit just booted finally. So this confirms we have a successful repair. Again, if you want to give this repair a try, we'll have the repair kit available on our website, which I'll link in the description down below. But it is an advanced repair, especially for that U1 chip. If you're not comfortable with those repairs, we do offer flat rate services. Again, those are available on our website, which I will also link in the description down below. If you found the video helpful or useful, leave us a like, subscribe for more content, and thank you for watching.